Eloisa, excuse. Okay, now it's online.
Can you hear me? Okay.
Yeah, Eloisa. Eloisa.
Okay, Beatrice.
Eloisa, excuse me now, because I told with Anders that there is a problem on
yes,
recording.
Okay, we know. Thank you very much. So, so how I was saying, okay, I'm saying that I'm so happy for having this presentation today. Your fame precedes you, so it's an honor for having you, a new member in our group, and so you could explain and talk about your beautiful work. We are anxious to know that, and maybe some others come joining us today. So, because there was much more people saying that would like to be here to attend it. Anyway, the session is going to be recorded, and then others can reach out to you. Okay? So please welcome to our group, and let's start it. Okay?
Okay. Thank you very much for introducing me to your group. And I know someone from you because we meet in Boston on Scratch conference 2 years ago. And I hope to visit this year's Scratch conference in Boston and MIT too. And my name is Pavel Frolov. I'm speaking now from Russia. And I would like to make presentation about Robo project. Robo is free and open source educational robotics. So let me try to show my screen. Now you should see my screen, and I would like to show you the presentation. I hope that everything is working good now. Do you see the presentation?
Yes, that's okay.
Oh, okay. So we offer everybody to develop the imagination, to code your imagination. And if you use the word education in Russia, it will sounds like образование. And the first letters in the word образование, образ, means image. So we strongly believe that good education should address the imagination of student. And if people use the imagination good, they can imagine something and then they can do this in the real world. It means that they educated good. So we are working on education. We working mostly on educational robotics. And now we see a very large market gap because most of educational programs are using proprietary software and proprietary devices. So children are not able to modify devices themselves. And as a result, they become users, but not innovators. And Robo and RoboClubs network bring new creative and gadget way to learn the basics of programming and technology using free and open source educational robotics. And we use both free and open source software and free and open source hardware. So we are seeking for partners to teach children from the age of 7 and maybe even age of 5. And we also working on using this technology to start a new successful business. So this is happy children from the Finland who are using robot technology. And we are will be happy when every child in the world will use our technology. So they will work hard to do this. So Robo is an educational set for creating smart devices. Our major devices name are RoboKit and RoboLab. and they don't require any prior programming knowledge. And they program in an open source visual programming language using MIT Scratch. We call it RoboScratch. And we have built this software for standalone applications for Windows, Mac OS, Linux, and Android devices. And also, we are using network of RoboClub, where we use our hardware, software, and curriculum to teach kids creative coding, microelectronics and schematics, mobile robotics, Internet of Things and smart house, and basics of 3D designing and 3D prototyping. So this is the image of our measure device. It's RoboKit. So I heard that many of you are using Arduino in your educational work. And in fact, this is a kind of Arduino on the wheels. So it uses the fully compatible Arduino microcontroller, and it uses magnetic mount sensors. So you can very easy use this on the lessons, and you can mix and combine different sensors and replicate any technology that surrounds your students, from smartphone to refrigerator. And I would like to tell you our history, so you will better understand why we developing this way. We were the guys who bring Arduino to Russia. It was 10 years ago, and they bring Arduino to schools and invite teachers to use Arduino in schools. But teachers was refused to do that. And they say that it's almost impossible to use Arduino in the lessons. They can use it only in small clubs where not more than 8 students can be in one time, because it's very hard to control the educational process, because Arduino should have a lot of wires, sensors, breadboards, and so on. So teachers asked us to simplify this solution, so we redesigned Arduino to make our 2 products. And also, we were the guys who was involved in first steps of bringing MIT Scratch to Russia. It was also about 10 years ago, and we do it with Intel company. And we do first Russian competition on Scratch. And we're still holding competition on creative coding. And we're thinking to make this competition worldwide sometimes, maybe next year. So as we had Arduino, as we have Scratch, we use this technology, and we get Robo. Our second product is basically the implementation of Scratch board, or it also can be known as Pico board. So this is fully compatible with Arduino board, and also it has buttons, slider, sound sensor, light sensor, some LED, sound speaker, and it's compatible with all Scratch environment as Pico board. So it's very good system to bring kids to the basics of the world of technology, to tell them the basics of Internet of Things, smart house, and all our devices are compatible not only with MIT Scratch, but also with Arduino, so you can use Arduino IDE to program these devices. So we have very easy to use solution, and we support teachers and motivate students to go to coding education. And we are developing in some countries where coding is just entered the school curriculum. and it's kind of Finland or Thailand or some other countries, and it's very easy to use robotic platform as educational tools for children to learn the basics of technology, engineering, and coding. And we specially design our solution for mass adoption for schools, for lessons, and for clubs. And we don't require prior knowledge from the teacher. And this is very important that any teacher can use our technology to teach kids coding. So it's ready to use, and we have complete advanced task within 10 or 15 minutes. And our products are designed and manufactured in Finland. And we developed our product in cooperation with Helsinki University and Department of Teacher Education and Finnish secondary schools from Innokas network. And all our products have CE certification. Our team is gathered by international professionals and creative people who work in the area of free and open source, like Linux software and Arduino hardware and so on, for education since 2000. So it's more than 17 years. And Robo is winner of Google Rise Award of 2013 and 2014. And we get an annual grants program from Google and educational coaching, how to use our solution for education in the best manner. Also, we are the winner of contest of Finnish government. It's named Finlanding. And Finnish government invites Robo to Finland to use our solutions in Finnish schools and to scale our project to other countries. And now we have two offices. One office is in Russia and another office in Finland. So we have more than 100 educational institutions worldwide which use Robo. It's schools and universities. It's 42 in Finland. It's 35 in Russia. It's 2 in Great Britain, 5 in Thailand, 1 in Spain. And also, we built our own network of Robo clubs where we use our own curriculum, hardware and software to teach kids, and we charge money for that to make a stable project which can scale very fast and in very stable way. So we have now about 40 opened Robo clubs in different countries, and last year we just opened one Robo club in China, and we're going to scale this all over the world. So we see now that educational market and market of educational robotics is growing very fast. We see high demand in learning skills for the future, like programming and digital literacy, and we see that this process is constantly scaling up, and we invite small companies to enter business of kids' education, of technologies and skills of the future. So we have franchising offer. We seeking for partners who can use our brand, and we give them all information how to make Robo Club and how to make this Robo Club profitable, to guarantee that teachers will get good salary and kids will get good quality of education. To open one Robo Club, the person needs to invest about 15,000 euro for all. As the partners, they get everything to start successful business. So it's Robo Products, it's guide to conduct business in our brand book. It's quality assurance of education. It's pedagogical guide, on-site training, and systematic assessment of teacher with certification. We support our partners during every step. We give technical support and advisory services, and we give several channels of income. So it's can be programming and robotic clubs, and can be holiday camps, and it can be some workshops. We consider our partners as the part of the Robo family, and we give the best condition for growth. And we expect that partners will follow quality standards, that they invest time and some money to build and develop business, and they give their own creative approach to education. And of course, motivation is already a big step to success, and we will help and support our partners in any step. So we consider that education can be the business, and it's the best time to enter business of educational robotics. Now I would like to show you a few pages of our website to let you find something interesting. So on robot.world website, you can go to materials section. I sent this link to the chat, and you can find our pedagogical guide. It's free. We have 37 lessons, and we have now 3 languages. It's English, Finnish, and Russian. And also here you can find our academic research. It's the design-based research project, which was done by Innokas project in Finland. This is innovative network of teachers, and they take a focus group of 174 pupils, aged from 9 to 16, and 9 teachers. They work more than 1.5 years on building this research, and after this research, this is published on our website, was born our robot teaching guide. So this teaching guide is the best approach of Finnish education, and it is very popular in different countries. For example, now we have very strong demand from Asia to our technologies. Also, I suggest you to visit our apps section, and here you can download our build of Scratch for Windows, for Mac OS, for different kind of Linux. And also you can make a Google search of Robo Scratch in the Google Play Market. And we have Android version of Robo Scratch, and this new year we also released the Robo Junior solution based on Scratch Junior, and we also have version for Windows, Mac OS, for Linux, and for Android. So this is a very short introduction of our solution, and I would like to have a section of questions and answers, and I leave a lot of time to this, so please ask your questions. Hello.
Hello, Frollo. Well, I want to welcome here to this group, and I'm very happy to hear all about your work, because I think most of all are looking the same objective in our countries. I have a team in Mexico, and I think we are in the same work like you, trying to find new things, and robotics is I don't want to be to know because it's the mode. No, it's not the mode only. It's what's in the way to be to have prospects and to have more students doing things with this imagination. And I took all about you are doing. I heard, but what was your first challenge when you start? What was your first challenge?
So our first and largest challenge still is teaching problem. So they see a lot of teachers who is afraid of new technology. They are not familiar with the computers. They are not familiar with robotics. And it's very hard to motivate them to not afraid, and they need not afraid. They need to love. They need to love coding. They need to love robotics. They need to love 3D printing, and so on. And this is the largest challenge for us: how to enable teachers to love this technology and how to make this come true to every schools of the world. And as I said, we have free and open source project, and we are expecting that teachers and kids will reproduce our solution by themselves. So we have a competition in Russia which invite kids to make robots. So we believe that we can stop education when kid is able to go to the shop to buy components to make and solve their own boards, then to make 3D printed and laser cutted design part and mechanical part, to combine and assemble everything together, to program it and give back to the teacher their own mobile robot, their own digital laboratory, their own control panel of smart house, their own controller of Internet of Things, and their own 3D printer and their own CNC machine. But we have almost no one to talk about this in the world, in the teaching world.
I think this is the real, for us in Mexico, the challenge was sometimes is the teachers, and sometimes is the schools. When you go to the schools to invite them to this new style of or learning, but most of the schools think there's only for competition.
Yeah,
and
it's also a big problem.
Well, but we don't have money to compete to competitions. But it's not only that, and how you can change that mind. And the robotics, it's not only for competition.
Our main message is focusing to parents, even not to the teachers, but to the parents. And we say to parents, please look outside. You see that robots is taking job from the people. There are some jobs that already this time totally terminated. For example, hand washing of dress. Now robot is washing the dress and its clothes dryer. Yes. So now there is no accountant who gives salary to the people, but ATM machines is giving salary to the people, and there is no any more job of accountants who give salary to the people. And the next profession which will be terminated is driver. Self-driving cars are coming in the world, and this process will be speed up very fast. And very fast we will see that people don't have job, and all job have robots. Yes. And then we will have, maybe we'll have communism with guarantee income and so on. And maybe we will have ugly capitalism when robots will be owned by a few people and other people will have problem with the life. But in any case, the people who have job in robotics, who can operate robot, who can program robot, who can repair robot, or who can make their own robot, they will have good job and good future in any case. So if parents are thinking about good job, they should teach kids robotics. And it's not about competition. It's about industry. It's about manufacturing. It's about service robotics and so on. So this is our message.
Competition for life.
Yeah, it's competition in life, not in game.
Yeah. Thanks.
may I have a question, Flor? In some parts, it's very similar to MBOT and XT. I'm looking in the teaching material in English. So I'm wondering why continue to build new products and not using product already existing and do the franchise. I mean, it's very interesting. What do you do about teacher formation, teacher support? This is very, very important. This is the point I think more important. But why to create hardware, more hardware? I mean, is aesthetically very, very nice. Your product is super. And also, I'm looking, I'm watching the website. It's very interesting. And but I wonder why we continue to build new products, you know, and not to focus about more about support or something less hardware. I don't.
Thank you for the question. The answer is that when we start our projects, it was about 5 years ago.
Okay.
So when we start our project 5 years ago, there is no free and open source robotics on the market.
Okay.
Our project was the first.
Okay.
So this is why Google was support us.
Okay.
After that, some good projects also was born, but if we talk about, for example, Lego NXT, which is kind of market leader in this education section, they are proprietary.
Yeah.
So they don't let kids to understand what's inside their microcontroller. They don't let the kids to understand what's inside this sensor, and it's forbidden to reproduce Lego NXT, but it's allowed. We have free license. Everybody can make their own copy of Robo, like everybody can make their own copy of Arduino. And for 3 or 4 years, we was the only solution on the market with these features. Now there are some Chinese projects which also open source.
Yeah,
like MBOT, like this. Yeah.
MBOT, I know, but sometimes it doesn't work very well. I mean, there is some problem in the hardware quality, I think. So maybe this is a point, the good point for your product. And in any case, so I think it is always too much defined, the robot. Could you someone create something less defined for youngest? I mean, a microcontrol or is something that they can't understand. They can't understand how electronics works, how circuits works. No, so there is other project they started to try to explain, but it's not enough at the moment. We need some project they can explain how SAPU circuit works, because you have your robot, no? There are sensor, but they don't really understand what it means a sensor. There is something more we need as a teacher, right?
Which age group you're talking now?
Until 12. Until 12.
Until 12. Okay. So we start.
If you ask a guy of 10 how ultrasonic sensor work, he could explain something, but not really how it works. Opening the sensor.
Yeah.
Maybe bigger. No, maybe bigger because you need. I don't know.
Okay.
Thank you.
If we're talking about age under 12, the first thing that we are focusing is to compete the Minecraft and other online games. Because after 12, we have a very big problem with kids who are playing Minecraft and other things, and they are not motivated to study anything. They just want to have their smartphone and tablet and play this. So this is why we start to teach kids as early as possible. So now in Russia, we invite kids from 5 years old to our RoboClubs, and we work with some kindergartens. And our first curriculum is based on playing. So we let kids to play, to make their own computer games on Scratch, to make their own robot theater, and to make their plays with robots, with some arts. And we use STEM. We use STEM robotics, and we use STEM robotics art. And if we put everything together, they got RoboStream. So science, technology, engineering, science, technology, robotics, engineering, art, and math. So we drive kids from simple things like playing something to more and more difficult things. And in Russia, in the age of 10, we let kids to do their own robots in do-it-yourself way. So we have do-it-yourself kit, which allow you to build your own robot and program it and use it as their own property. So kids can make the robot, and they can take it home and then show to the fellows. I will try to show you the picture of this robot, but my internet connection is not very good, so it's not opening still. But when so now it opened, I will show my screen and show you the picture. Wait a minute. This is so this is the robot. Do you see the picture?
Yes, we see.
Yeah. So let me tell you a few words about this robot. So we give to kids components. It's Arduino, it's breadboard, it's motors, wheels, and some sensors. And first of all, kids should decide how this robot should look. And then they make 3D model of this robot, and then they print this 3D part of robot on 3D printer. After they make everything printed, they assemble everything, mount all solution on breadboard, and then they can make program. And they can program this solution by App Inventor, MIT App Inventor, by ArduBlock, by Arduino IDE. And this is a very good way to make very deep understanding how technology works. And in our curriculum, we understand that kids are not familiar with this technology, so we think that we can be the first people who tell them about electricity, about electric schemes, microelectronic schemes, how different sensors are work, and how they can use this sensor to make some useful job. For example, move out from the maze, find the best speed on the line racing, and so on. But the most important focus for us is to use creative competition, not robotic sport competition, but creative. How good is your solution? How smart is your solution? How much passion you put to the solution? So this is the question.
Okay. For example, this robot you showed. How old are the kids who made it?
10 years.
10 years.
10 years.
And they are from a private club or from a school? How is it? I would like to know, how do you, because you have this robo clubs, that's a big network.
Yeah.
And you have some schools involved in these activities as well. So these schools that are related to your franchising, your equipment and hardware, everything, are they, sorry, I don't know if are they private school or public school? How could you talk a little bit, how is it in Russia? I don't know.
Okay, so mostly we are in Russia and in Finland. And we have two models. One model is when they developing our own robotics RoboClubs network, and another way is using existing schools. So if we go to existing schools, we give them hardware, software, teacher training, and curriculum. And if we open our own RoboClub, we do after-school lessons, weekend lessons, and vacation camps. Mostly on summer, but also in autumn, winter, and spring. And we just have very successful sets of RoboCamps in London, in England, in Great Britain. So this robot that you see is the graduate project for the RoboClub. So after first 60 lessons, kids have basic understanding on coding, on microelectronics and schematics, on mobile robotics, on IoT and smart house, on 3D printing and 3D prototyping. And after he has or she has a basic skills, we invite to choose graduate projects. And this graduate project might be your own computer game, your own robot, and also it might be your own 3D model, which you will 3D print. And I also would like to share with you the picture of our 3D printer. It should appear here, I think. Here it is. I hope you see this. So this is our own do-it-yourself 3D printer, and you can order this in assembled one and in disassembled way. So you can assemble this 3D printer with your students and let them understand very good how the 3D printer technology works. And then you can 3D print the parts of the robot, like robot arm or the whole design of the robot, like this one. Okay?
Okay, and could you please tell us how do you work with public schools in Russia? How is the acceptation? How can you make it work with the curriculum, the basic curriculum? Do you have a basic curriculum in general? Just to have an idea, please.
Yeah, so in Russian schools, we built 3 curriculums. One curriculum is for age group 5 and 6. Other group is the age of 7 and 10. And third curriculum is for 11 and 14. So each curriculum has 60 lessons for each year. And on first level, we are using the technology. Then we go deeper and deeper in technology from year to year. And if we work with public schools, first of all, we invite teachers to a special training program. It lasts for 1 week. So it's offline education. So teachers come to our training center for 1 week. We show them everything, all technology solutions, and also they are involved in kids' education. On the last day, they should make their own lesson for the kids and make it with real kids in the best way. Or if they don't have kids in this time, they make this lesson for other teachers. So after that, they should pass the exams, and they should make a wiki page with their own project. They should make their own Scratch project and their own lessons and so on. And we are using project-based learning. So also they should have passed the exams on project-based learning. After teachers are ready, we ship to the schools hardware. They give for free our software, and we have the full stack of free open source software, build it on Linux distribution, and we give them software for educational task, for engineering and creative things like 3D design, 2D design, making your own electric schemes and circuits and so on. And we give them also solution for sport programming. And then we give them on-site support. Okay?
Okay, and how is it? How is the acceptance from the schools to your projects and hardware and softwares? And how can you enter the schools and offer? They are open, or is it difficult? How challenging is it for you?
Yeah. So
because you have been there for many years already. And
yeah.
So.
For us, it's still very hard to go to the schools, and this is the reason why we do our own network of RoboClubs, because parents are willing to teach their kids all this technology, but schools are not ready, at least in Russia and in some European countries, which is close to Russia. We only enter the schools, kind of innovative schools with innovative principals who make teachers to go to this area. And first half a year, most of teachers are unhappy on this because they don't like the technology. We have only small amount of schools with the very very motivated teachers who want to be involved in all new. But typical situation that teachers are not happy, that principals say to them that they should teach kids robotics and coding and 3D printing and so on.
Okay, so if I well understood, although they have this on the curricula, the things happening is not right as good as they propose it is. Am I right?
Yeah.
Okay. Yeah, I think it's similar.
The motivation.
Okay, I think it's a general worldwide problem. Okay, okay. So, people, do you have any other questions? So I would like to open to others to make some more questions before we finish.
I just had a
please go on.
Great.
Yes.
I just had a hi. I recognize you can scratch. I just had a quick question. Are these available on Chromebooks at all? It didn't look like it.
We are not tested last version of our software on Chromebooks, so I think it should work, but I cannot guarantee this.
Okay, that's all we have in our schools for the most part right now, and I don't see us making a change, so I'd have to be able to test it out before I could recommend it.
Yeah, but if our customers will ask us to make the version for Chromebook, we will do that.
Great.
It's not a problem. Yeah. Okay. Do you have some more questions?
Anders, would you like to ask something? You didn't say anything. No. Yes, please.
Okay.
Yes, maybe I stuck with one question, I think. How did you found this huge company, or what it is? Where did you get the money from the first time?
So first time we get money from Russian government.
Oh, so they founded, yeah.
Yeah, so they give us a kind of grant finance to make this as an innovation project. And our second donor was Google company, because we won Google Rice Award. So this Google Rice Award also provide us some money.
And in the moment you are financing yourself,
yeah,
with courses, yes. Yeah. Okay. I think it's very interesting, the robot, what you call that. So I saw you had some magnetic sensors. You just click them on.
Yeah, yeah. So you need only 1 second.
So you can use a couple of sensors if you like, and you can use it without sensors.
Yeah, yeah.
Okay, so you don't have to have all those wires and
no wires.
Oh, okay.
You need only 2 or 3 minutes to prepare the large classroom. For example, for 30 robots and 30 computers, you need only 3 minutes to prepare everything and make exercise.
Yes. And how do you communicate with the robot? Is it a Bluetooth, or is it a cable?
You can use both option. You can use Bluetooth and you can use USB cable. And we find that teachers prefer to use USB cable, because if you use Bluetooth, you need to charge batteries. And if you ask teacher to charge 30 batteries before each lesson, the teachers say that you should go out with your solution.
Yes, I understand. But you can the robot in itself is you can charge the robot.
No, you charge battery. So we use 9-volt battery.
Okay.
You can buy it separately in your nearest electric warehouse, and with charging solution, and you can use it, but usually the teachers use it only on kind of competitions and shows and so on. But on the lessons, it's much more easy for them that they not to charge anything, and they can get electric power from the cable, from USB.
Yes, and you have the cable when you are trying it out.
Yeah.
And then you can unplug the cable. And,
yeah.
Okay, I understand. So you have to send a robot to me.
You can make an order on the website. It's very easy.
Yes, but
you can ship it to any place of the world.
Maybe it's the cost.
No, we have cost. Sorry.
Well, have you any problem about communication if you use more than 2-3 robots contemporarily, simultaneously?
Yeah. If you use about 10 robots in one room with Bluetooth,
Yeah, yes, a
You will
problem.
have some strange.
Yeah, some strange. Okay. And also in our makerspace, we started to use. You mentioned Minecraft. We started to use MBOT with Minetest. We are open source model, no, in our makerspace. So we use Minetest combined with MBOT, so you can maybe, I don't know, I think it's possible to do the same with Robo. You mentioned about 12. The children of 12 they are not so much interested, but if you work with these two kind of device.
Okay, yeah. Thank you.
Thank you. Thank you.
So I'd like to thank you very much, Pavel. It was a great presentation. We really appreciate it. And I think you got many friends here. So, during the session, many of the other peers from our group contact me saying that they could not because they are teaching, they are in working hours. So they are going to watch this video later. That's why we are recording. And maybe you have more contacts or questions later. Okay?
Okay, thank you. I'm open to answer.
Okay, thank you very much.
Thank you.
Thank you very much also. Great event.
Bye-bye. Thank you very
Bye-bye.
much.
Have a nice day,
Bye-bye.
morning and evening.
Bye, Veronica.
Anders, please
Bye-bye.
don't turn off.
Eloisa.
Bye-bye. Ci
Bye-bye.
parliamo dopo, d'accordo?